Well, hello, welcome back for week 3, and we will be talking about higher ordered polynomials. And so before we get right into, what is a polynomial and how are we going to solve these, I did want you to sort of add underneath this word here, let's write the parent function, okay? X to the n. Now the parent function can actually be way more complicated than this, but a polynomial is anything where x is raised to a specific power, and that power can be a 1, a 2, a 3, a 4. So technically you've been doing polynomials because linear functions, x to the first, those are polys. X squared, quadratics, those are also polynomials. So today we talk about the higher ordered. So that's going to be, x to the third, x to the fourth, x to the fifth. It can be as large as it wants to be. Of course, there could also be other terms behind it. Okay, so that's what we want to talk about today. So what is the goal and the process? Well, the goal for you guys in precal and really the rest of your math career is we want to know the shape and properties of each graph and properties of the polynomial. And our goal is to know them fairly quickly. You're not going to have to know exactly what the graph looks like. Well, okay. Let me correct that. Sometimes you will need to be able to find each and every part of the graph. But my goal for my students was always when they see an equation, I want them to have a general shape and idea of what this is looking like, okay? So that we can match data to real world situations and things like that. Now, there are some important parts of a polynomial that you will have to find from here on out, okay? You're going to need to find, in terms of shape, something called the end behavior. So this is basically like the end behavior is what's happening on the end of each graph, like on the left of the graph and on the right of the graph. Is it flatlining? Is it increasing? Is it decreasing? What is happening? And the way that you write this answer usually is with interval notation. So usually when you go to answer the question, you're going to have a parenthesis for interval notation, and then you're going to be telling me on the left where is the graph heading, and then on the right where is the graph heading. And so there's a couple of things that can happen. You want to look at the n. You want to look at the exponent on the problem, the highest exponent on the problem, and that's going to tell you everything you need to know. If n is even, if it's a 2 or a 4 or a 6, if n is even, guys, you've been doing these since 9th grade. It's going to look sort of like a parabola, at least on the ends, okay? So in the middle it could be doing all kinds of funky stuff. But if n is even, 2, 4, 6, 8, then you're either going to be, probably going up on the left and up on the right, just like a parabola. Now, if it's a negative in the front, you know how you could have a negative in front of a term? Well, if it's a negative, remember that reflects your picture, so it might be going down instead. So I used to tell my class, just look for even and think of a quadratic. If a quadratic's either going up or if it's going down. And your teacher's going to want you to write this with interval notation. So if it is going up on both sides, it'll be infinity, infinity. Or if it's down on both sides, it would be negative infinity, negative infinity. So that's in behavior if something is even. Now, what if it is odd? Okay, if n is odd. Well, if n is odd, I used to tell my class, well, what's an odd parent function that you know? What about x to the first? Do you know what x to the first looks like? I think most people do. Most people know that it's that diagonal line that kind of looks like this. So if you think of x to the first, you know that it's going down on the left and it's going up on the right. And you could write the interval notation like that. Or what if there was a negative in front of this, like negative x? Well, negative x would just go the other way, so maybe that would flip this. So if it's odd, these are always alternating. If it's even, it's either both up or both down, and you just have to think about if it's been reflected or not. So that's in behavior in a nutshell. You're also going to be asked to find the Y-intercept, which is a gift from God, honestly, because to find a Y-intercept, it's probably the easiest mathematical thing ever. A Y-intercept happens whenever your x is 0. So like that's literally all you have to do to find it. You just plug in 0 for x. Plug in 0 for x, and that would be your Y-intercept, okay? X-intercepts, they will be the trickiest thing to find. I'm going to put a star by them because that's going to be where you don't like this, okay? I'm going to keep it easy because this is just an introduction. So all of mine are going to factor, all right? Now, you do want to try to factor first. So if you can factor your expression and solve it, then you are in business. Now, the difficult ones, I'm just going to kind of have you write a note right here because like I said, we're not going to get to it. But when you do this in class, the hard type problems, they get harder whenever they don't factor, and then you have to use synthetic division. That should ring a bell. I think you did synthetic division in Algebra 2, maybe at the end of the year. If not, you know, you will definitely do it in precal, okay? But today ours are going to all factor, I hope. Okay, and then what else are we going to find? I think that may be it. Then we're going to try to sketch the graph. Let me peek ahead what all we want to work on today. Yeah, that's it. So once you have this done, then it's just putting these pieces together to sketch a graph, sketch a reasonable graph. And these graphs can get crazy, all right? It's not just a parabola or just one little curve. I mean, I've seen these that can look something like that. I mean, they can get crazy. And until you're in calculus, like, you don't know how high and how low these go. You know, these minimums, these dips, these waves. You're going to have to kind of guess the hills and the valleys and where they are. And I know if you're a perfectionist, you will not like this unit because you will be doing a lot of guessing. You know, you'll graph this and then go, okay, maybe it looks like this, and you'll have to kind of piece it together. So let's get started. Now that you have sort of the notes on how to do it, let's take one problem, and this is going to be our one problem for all the rest of this, and you're going to use this as your guide, okay? It says to sketch the graph of blah 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 blah. Okay, so when you see an equation like this, there's no transformations that can be done. You can't say, oh, well, I'm going to dilate it and then I'm going to shift it. Okay, no, it does not work that way. If this is all expanded out, we have to follow those rules from above. We're not able to just do transformations. So for end behavior, I always look at the leading term, or the highest powered term, and that's going to tell me everything I need to know. So in this problem, the highest powered term is 2x to the 5th. And so what I notice is that the exponent is odd, okay? So if the exponent is odd, I need to be thinking about another odd parent function that I already know, which is y equals x. And so with y equals x, it's that diagonal that goes like this. Now, how do I know it looks like this and it's not the diagonal that goes the other way? Well, there's no negative on the front of that. So since that stayed positive, then it has not been reflected, and I know it will look sort of like this. Now, in the middle, it might do all kinds of crazy stuff, but at least on the left, I know it's going down, and on the right, I know it's going up. So what a lot of teachers do is they don't draw that entire line. They just sort of write the end behavior. They may say, okay, it's going down on the left and up on the right. That's another common thing that teachers write. So you can erase that or whatever you want to do. Okay, so there's my end behavior. Now my y-intercept, like I said, easiest thing ever. It's whenever the x is equal to 0. So I'm just going to take my expression and plug in a 0 for all of my x's. And when I do that, I math it out and I get 0. So that one was pretty dang easy. And now we need to find our X-intercepts. So the X-intercepts I wrote above, this is where we factor and solve. And even though that looks bad, I'm promising you we're going to be able to solve this out, okay? So what I would do, you can't do like a quadratic formula because this is not quadratic. If it was quadratic and it didn't factor or something, then you could totally do a quadratic formula, okay? But for now, I'm just going to try to factor it. So there is an x in all of these terms, okay? So when I take out an x, I get 2x to the fourth minus 5x squared minus 3 equals 0. And I think that we may have already discussed interesting types of factoring, but if not, what's cool about this is anytime these factors are in a relationship of 2 to 1, you can pretend that it's a quadratic and you can factor it just like it were a quadratic. You know that whole thing where you're doing the guess and check? So pretend it's a quadratic, and so you need to be thinking of it like this. I guess technically though we need to put a squared on each of those. But it's the same stuff as before. So two numbers that, this is going to be a 3 and a 1. So either the 3 goes here and the 1 goes here or vice versa. But I need to make a -5 in the middle once I FOIL all that out. So for me, I feel like this probably needs to be, I don't know, let's see, we need it to be, I think the -3 needs to be here and the +1 needs to be there. And then I'm just going to check myself by foiling it in my head. That's a -6 plus a 1 minus 3. So that does work. Okay, so this is how I would factor it. And then to solve, it just means I'm setting each of these 3 equal to 0. So x would be equal to 0. 2x squared plus 1 would be equal to 0, and x squared minus 3 would be equal to 0. So when I solve this out, this one's already done. So since x equals, that's already done. So one of my x-intercepts would be 0, 0. This one I would try to solve, so maybe I would move the 1 to the other side and then try to divide by the 2. And the minute I get here and I try to take a square root of both sides, this is bad because that's a negative. So if I try to take the square root of a negative, it's going to be imaginary. So that just tells me that there's no real solution that goes with this factor. So I don't have to worry about it, in other words. And then over here I'm going to do the same thing. I'm going to try to solve this. So I'm going to move the 3 to the other side, and then I'm going to take the square root of both sides. And remember, when you take the square root of both sides, you do need to have that plus or minus. So the factors that come from here is a positive square root of 3 and a negative square root of 3. Okay? So now that I have all the important information, I'm going to try to make a graph. So all of these things that I'm circling need to be on my graph, okay? So how do I do that? Well, I'm going to start by just sketching, my x and y axis, and I always put my intercepts down first. So my intercepts are 0, 0, and then these two. Now we're going to have to approximate, okay? The square root of 3 is close to the square root of 4, which means it's close to 2. So it's like a 1 point something close to 2. So it's probably right in there. And then a negative of one of those. Alright, so I've got these 3 points, and I need to snake them together. So I've got to decide, do they kind of go together like this, or maybe it's the other way around. And the way you decide that is from your end behavior. So I know it's supposed to go down on the left. So what I usually do is go to the far left point and draw my down arrow. And then I go to the far right point, and since that says positive infinity, I'm going to draw my up arrow. Then I connect the dots in between. Now, like I told you, I don't know how high or how low this graph goes, and you will not either. It is called do whatever you want, like just make an educated guess. If you want to know exactly, how high it goes or close to exact, feel free to pick a number in here and plug it into your equation, and get the y and see how high it goes. But that's only if you really are worried about it, because your teacher won't be that worried about it. You just want to figure out kind of what this looks like. And so that is the graph for what we did above. You can look on the calculator and see how close we were. I'm guessing we'll have to adjust or fudge one of our hills, but other than that, you know, we're pretty good. So I'm going to have you guys try the 4 problems on the practice, and the directions are pretty vague. I mean, you just have to do this whole system with each of the 4 problems and try to get a sketch. When you're done, you know, please check yourself on a calculator, on a graphing calculator if you have one, so you can see how close you were. And then of course I'll come back and talk you through the how to do it by hand, just in case, you know, you're curious about that. Awesome.